In this video, I want to talk about how to use a graphing calculator to solve a word problem involving a local extremum of a polynomial function. And so we're looking for, this is a problem where we're going to use the maximum or the minimum of a polynomial function in order to find the answer to the problem, and we're going to use the graphing calculator and we're going to use it in ALEX. So I'm right here in ALEX to show you how to do that. Okay, so this problem says a box with a hinged lid is to be made out of a rectangular piece of cardboard that measures 3 inches by 7 inches. 6 squares will be cut from the cardboard. 1 square will be cut from each of the corners, and 1 square will be cut from the middle of each of the 7-inch sides. The remaining cardboard will be folded to form a box and its lid, just like this. Okay, so now it says letting x represent the side lengths in inches of the squares, use the graphing calculator to find the value of x that maximizes the volume enclosed by this box, and then give the maximum volume. Okay, so the first thing that we need to think about is that the volume of a box is equal to length times width times height. So when we're trying to find an equation for the volume, we need to be looking at length, width, and height. Now, the height of this small box, you should be able to see, is going to be x. So the height of the box is x. The length of the box is going to be like one of these, right? So this will be the length of the box, and that's going to be 3 minus x minus x. So 3 minus 2x. And I'm going to write this in just a minute, but let's just figure it out first. Okay, and then the width of the box is going to be one of these guys. So the question is, what is this guy? So it is 7 minus 1, 2, 3x divided by 2, because there's 2 that are identical. So 7 minus 3x divided by 2. Okay, so when I go to write my equation, I'm going to get, alright, so I'm going to get volume is equal to x, which was the height, and then the width was 3 minus 2x, and then, or the length, I think I said that was the length, and then, so the length is this, and then the width is 7 minus 3x divided by 2. Okay, so 7 minus 3x divided by 2, and then 3 minus 2x. Okay, so I think that this is the right volume over here. So the volume is length, or height times length times width. Now, you could simplify all of this out, but using a graphing calculator, you don't actually have to. So you don't really need to simplify it. We just need to put it into the graphing calculator. So if I go ahead and go back to my graphing calculator, I want to go to y equals and put in x times 3 minus 2x times 7 minus 3x over 2. Okay, and now I should be able to graph this, and I want the x value that maximizes the volume. So I'm looking for the maximum, which I believe is going to be right here. So in order to find that x value that's going to maximize the volume, I'm looking for this x value, because this is the volume And so we can't consider any of these volume pieces over here because we're getting close to 3, and x cannot definitely not be 3, right? The most x would be like 1.5, and even then you wouldn't have a box at all. So x definitely can't be more than 1.5. So x needs to be somewhere in between 0 and 1.5, and so the maximum is going to be this maximum here. So if we click extrema, and we want to drag our bounds so that we're finding this one. I'm going to hit OK. Oops, I was supposed to hit maximum. Let's try this one more time. Okay, let's hit maximum. Okay, and I find my result is the value of x that maximizes the volume is 0.60 if we round to the nearest hundredth, 0.60, and then because we round that up, but that rounds up so 0.59 rounds up to 0.60, and then we have 2.81. So that is the maximum volume is 2.81, and I can go down here and check my answer, and it's correct. Oh, and they're telling me to start with a 0.60, which is fine, but it'll take it either way. So that's how you use ALEK's graphing calculator to solve a word problem involving a local extremum of a polynomial function.